Okay, here's the recording I said I'm gonna record. So for 3.1, I think we can agree that we would know what to do with 3.1 when it comes to finding the derivative of a function using first principle. So that is well captured in our first session of calculus. So let us go to 3.2 to differentiate different types of functions and different compositions, how the functions are put together. So 3.2 reads, use differentiation rules to determine the derivatives of each of the following, leaving your answer with positive exponent in a set form where applicable. So this is very important. Don't jump this. Your exponent must be positive and then it should be left in a set form where it is applicable. So we do not choose, for example, when is it applicable or not. So for example, if the final answer was to be 1 over 5, you have to change it, and that would be the fifth root of x. If, for example, you had x to power negative 1 over 2, remember, bring it down so that the exponent becomes positive, and then that is going to be the square root of x. So that's what it means. We already know how to make the exponent positive. So let us go to 3.2.1. So for 3.2.1, everything is ready for differentiation because you have the power, you have the log, you have 4x, you have the constant, so we are good. So this is going to be f prime of x. The derivative of 3x squared is going to be 6x because you drop the 2, so 2 multiplied by 3 would give you 6, and then when you subtract 1 from 2 you would be left with 1. And then me and you have agreed that the derivative of ln x is always going to be 1 over x. So 1 over x multiplied by 2 would be the same as 2 over x. And then the derivative of 4x would just be 4. The derivative of 5 is 0. So that would be the answer for 3.2.1. For 3.2.2, you check. So I see a problem here. We need to fix this because it should be in the power form before we can differentiate it. So I'm going to say f of x, therefore I'm not at differentiating. So remember, according to the laws of exponent, the number inside, which is 2, gets divided by the number outside, which is 3. And then the next term is fine. And then the next term is also fine. But for your syllabus, you are no longer covering these cosecant. So I'm going to ignore the cosecant. Or I can just do it for your fulfillment. But it's no longer covered in your syllabus. Okay, now all of these things are ready. Now I'm not going to write equal sign, but rather I'm going to say f prime of x equals. So for this, I'm going to drop the exponent. So I'm going to drop 2 divided by 3. And then from 2 divided by 3, according to the power rule, I'm going to subtract 1. And that will give us a negative 1 over 3. And then plus the derivative of e is e itself. And then we have 2. But remember that you have to multiply the answer by the derivative of 3x. The derivative of 3x is 3. And then the next part, the derivative of tangent is secant squared. And then you multiply the answer by the derivative of what is inside tangent, which is 2x. So the derivative of 2x is 2. Now, if this was still part of the syllabus, the derivative of this is going to be negative cosecant 3x cot 3x, and then obviously you would multiply the answer by the derivative of what is inside, which is going to be minus 3. I mean 3 rather. But like I would have indicated, please note that this is no longer part of the syllabus. So I was just doing it for your fulfillment. So let's go back to what is actually relevant. So this must be left in with a positive exponent in a set form. So this is then to say you're going to have 2 divided by 3. And when you bring it down, it's going to be positive, and it's going to be the cube root of x. And then the second part, 2 times 3 is 6. So that's going to be 6 e to the 3x, and then minus 2 secant squared 2x. So this is going to be the desired answer. Ignore the cosecant. It's not covered in the syllabus as I have indicated. Then 3.2.3. So this is quotient rule. So it is ready. So I'm going to say dy over dx. Me and you have indicated rather clearly that when you are doing the quotient rule, you find the derivative of the stuff on top. So the derivative of the stuff on top is going to be 3x squared. And then you multiply by the derivative, you multiply it by the stuff at the bottom. So the stuff at the bottom is x squared minus 3x. And then the rule says that you then subtract, and then you keep the one on top. So the stuff on top that we need to keep is x to the third plus 3. We keep that stuff. And then according to the quotient rule, then we have to multiply then by the derivative of the stuff at the bottom. So the derivative of the stuff at the bottom is going to be 2x minus 3. And then from here, you simply square the stuff at the bottom. So that's going to be x squared minus 3x all squared. And that's it. Usually you are not expected to simplify that thing. That is why that thing is just 3 marks. And then 3.2.4, it is ready. So we're going to say dy over dx. That's chain rule. So differentiate the stuff outside. So the stuff outside is the power rule. Drop the 5, and then from the 5 subtract 1. So 5 minus 1 is 4, and then the stuff inside remains the same for now. And now we have to multiply by the derivative of the stuff inside. So the derivative of x to the third is going to be 3x squared. The derivative of minus 5x is going to be minus 5. And that would be it for the differentiation. Please go back to the previous 2 recordings. They record the rules very well. There are so many ways that they can ask the questions, but make sure that you are put together when it comes to understanding the rules of differentiation. Okay, the other aspects, this is the application I referred to when I was talking to you earlier about what we're going to be doing today. So I'm gonna explain through answering questions. So we are given a function f of x, which is x squared minus 4x minus 5. And the question says determine the equation of the tangent, which is the tangent is always a straight line. So tangent is always y equals to mx plus c. So I can guarantee you when you are writing anything to do with calculus in level 4, they will ask you this question. But it's very easy to work out. So what do you need for you to be able to get the tangent? 2 things. You need the gradient, and you need 1 point on the function. So 3.1, we know that the value of x is 3. So we can get the corresponding value of y by replacing x by 3. So we can get f of 3. So f of 3 is going to be 3 squared minus 4 multiplied by 3 minus 5. Pressed in the calculator, that's going to be minus 8. So it means that we have a point which is x and y. Our point x and y is at 3 and minus 8. And the next thing that we need is the gradient, the value of m. Remember, when you take the derivative will give you the gradient m. But this time around, we are looking for the gradient when x is equals to 3. So it means that for us to get m, we have to find the derivative of the function. So the derivative of that function is going to be 2x minus 4. And then for us to get the actual value, we're going to say f prime of 3, because we are interested in the gradient when x is actually 3. So that's going to be 2 multiplied by 3 minus 4. That's going to be 2. So it means that we have now a straight line which is y equals to m. M is 2x plus c. So we need c. In order for us to get c, we need to know one point at least, x and y. We do already. So where you see y, you would put minus 8. Where you see x, you would put 3 plus c. When you compute c here, I think it's going to be minus 14, and therefore the equation of the tangent is going to be 2x plus c. Our c is minus 14. So this is how we find the equation of the parabola. I mean, not the parabola, the tangent. When we engage live, we will expand more onto this, or I can also do a few recordings as well. But whenever you're looking for a tangent is a straight line. You need to know the gradient, and you need to know the value of c. The value of c is the normal mathematics. We know how to find the value of c. But the gradient part is where what we mean when we say the applications of derivatives. So when you find a derivative of a function, you actually have calculated its general gradient. But when you substitute the value of x by a certain value, now you pinpoint the gradient at that specific value. So for this particular question, we are interested exactly where x equals 3. So that's how that runs. Then 3.2. 3.2 says that we are given a function x to the third plus x squared minus 12x. So it says determine the x-intercept of f of x. So remember, x-intercept is when y is 0. So it means that you're going to take all of the thing and set it to 0. Now here, this question is entirely a normal question. So if you check, we've got 3 terms, all of them are carrying x. So take out x as a common factor. And then we're going to be left with x squared plus x minus 12 equals to 0. So it means that the other value of x is going to be 0. Then you factorize this. Open 2 brackets. So the vectors of x squared are x and x. The factors of minus 12, that would give you positive 1 in the middle, would be positive 1 and minus 3. So therefore we're going to have x equaling positive 3 or x equaling minus 4. So they wanted x-intercept. So it means that we have the x-intercept at 0 and 0. The other one is at 3 and 0. The other one is at minus 4 and 0. Remember, we only have x-intercept when the value of y is 0. So that is what we are talking about there. Okay. Then the next question says the y-intercept. Remember, the y-intercept is when x equals to 0. So because you have got x to power 3, x squared, and minus 12x, when you replace x by 0 in each and every term, all the terms will disappear. So for 3.3, we're simply going to have 0 and 0, because, like I said, when you say 0 to power 3 plus 0 squared minus 12 times 0, going to get 0. So y-intercept is very easy to work out. Now, here's the question now that talks about the applications of derivatives. How to find the coordinates of the turning point of f of x. So let us explain. So 3.3.4, I think 3.2.3 rather. Remember, our f of x is x to the third. and then plus x squared, and then minus 12x. For us to find the coordinates of the turning point, you will find the first derivative, you set it to 0, then you solve for x. Let's do exactly that. So the first derivative, that's going to give us a 3x squared plus 2x minus 12 equals to 0. Then you solve for x here. So there is no need for us to waste time. We can just go to the calculator and press this in the quadratic formula. So if I quickly do that, I'm gonna arrive with the following numbers. So the first answer is at 1,69. And then the second answer, when I subtract, is gonna be at negative 2,36. Now you have the x and the y. You have the x coordinates at the turning point. Remember that the cubic function turns twice. So this is not complete because remember a turning point has both the y coordinate and the x coordinate. So we need the y coordinate. So you're going to find f of 1,69, and then you're going to find f of negative 2,36. So it means that we go to the original function and then substitute there to get the corresponding values of y. So if you do that, then we're going to have for the first one so negative 2,36 will give us a 20,75. And then the other answer, which is a 1,69 plus 1,69 squared minus 12 times 1,69. So that will give us negative 12,60. Negative 12,60. So it means that our turning point number 1 is when x is 1,69, and then when the value of y is 12,60. And then turning point number 2 is when x is negative 2,36, and then when y is 20,75. So that's how you calculate the turning point. You do the same thing over and over again all the time. So there is no deviation from the rule. But like I said, when we go live, we will emphasize more. Okay. Then the 3.2.4 wants us to determine the point of inflection. Again, that is the question that presupposes derivatives. 3.2.4. So for point of inflection, what you do is that you find the second derivative, you equate to 0, and then you solve for x. So we have the first derivative already. Our first derivative, we found it to be 3x squared plus 12x minus plus 2x minus 12. So you find the derivative of this thing again, so it becomes the double prime. So when you find the derivative of this, it's going to give you 6x. The derivative of this is going to give you 2, and you set it to 0 and you solve for x. So you have 6x equaling negative 2, and then x therefore is going to be negative 1 over 3 when you divide both sides by 6. And then you find f of negative 1 over 3. So you're going to go to the original function and you're going to find negative 1 over 3 all to power that plus negative 1 divided by 3 all to power 2 minus 12 multiplied by negative 1 divided by 3. Remember, a point is a coordinate. So that's what we are looking for. And the calculator actually here will give you 4,07. So our point of inflection is going to be at minus a third and then 4,07. So that's how you find the so-called the point of inflection. So that is how it is found. And then 3.2.5, I will show you clearly how to sketch cubic functions. For now, I wanted us to attend to the actual applications of derivatives to the functions themselves. So let's carry on to the next question. So for this question, we are given a function f of x, which is x to the third minus 8x squared. The first question, 2.3, says that we have to determine the equation of the tangent y is equals to mx plus c at x equals to 1. What do we need? A point and a gradient. How do we establish the gradient? The gradient, remember, m is f prime, but they told us at x equals to 1. So what you do is that you're going to find f prime of x. So that's going to be 3x squared. That's going to be minus 16x. That's when you find the derivative of that. And then for you to get m, you have to replace x by 1. So that's going to be 3 squared minus 16 times 1. There's going to be minus 13. So it means that our function updated is going to be minus 13x because we know the m plus c. For you to get c, you simply need to know another point on the function, but they've given us the value of x. So the value of x is equals to 1. So you're going to find the corresponding value of y by replacing x by 1 in the original function. And this is going to give us minus 7. So we have a point at 1 and minus 7. So what then we're going to do, where you see y, you're going to locate minus 7. Where you see x, you're going to locate 1. And then when we solve for c, that's going to be minus 7 plus 13, and that's going to be 6. Therefore, the equation of the tangent is going to be the gradient, which is minus 13, and c, which is 6. So this is the equation of the tangent for that given thing. Remember, this is the applications of derivatives. And then when you go to 2.4, 2.4 says you are given f of x, which is minus x to the third plus 4x. Number 1, determine the x-intercept. So we're going to have 2.4.1, take that thing and set it to 0. But if you check it properly, x is common between the terms. And then which means that one value of x is going to be 0. And then when you set this thing to 0, you're going to have x squared equaling 4. And then x alone is going to be plus or minus the square root of 4, which is 2. So it means that our coordinate is at 0 and 0. And then another coordinate is at positive 2 and 0. Another coordinate is at negative 2 and 0. That's your typical solve for x question. And then 2.4.2. 2.4.2, they want you to determine the y-intercept. The y-intercept, it means that you replace x by 0. If you go to f of x and replace x by 0, you're going to get 0. So the y-intercept is going to be at 0 and 0. And then 2.4.3, this is where calculus matters. So the coordinate of the turning point. How do we get the coordinate of the turning point? So that is 2.4.3. Find the first derivative, set it to 0, solve for x. So the first derivative we already know from the tangent. So that is 3x squared minus 16x equals to 0. Solve for x. So you're going to take 1x outside, and we're going to be left with 3x minus 16. All of this equals to 0. X is going to be 0. That is x. And then the stuff in the bracket, when you set it there, you're going to have 16 going to the other side, and you're going to divide it by 3. But we need 2 points. Remember, we're looking for the coordinate. So we need to find f of 0. F of 0, like we said, is going to give you 0 because you're going to replace each x by 0, and then everything will disappear, which means that turning point number 1 is going to be at 0 and 0. And then the next thing is to find f of 16 over 3. So you're going to go to the function, you press minus, you open the bracket, and you're going to say 16 divided by 3. You're going to close the bracket to power 3, and you're going to say plus 4, open bracket, 16 upon 3, close bracket, equal sign. And this gives me negative 130,37. So it means that turning point number 2 is at 16 divided by 3, which is 5,3, and then negative 130,37. And then number 2.4.4, allow me to do it here. It wants the coordinates of the point of inflection. The point of inflection, you find the second derivative. You set it to 0 and you solve for x. So here is the first derivative. Derive it again. So it's going to give you 6x minus 16 equals to 0. X will be 16 divided by 6. So 16 divided by 6 is 8 over 3. And then you're going to find f of 8 over 3. What is the meaning of this? You simply substitute 8 over 3 into the original function. And then this gives me negative 24 over 27. Negative 224 over 27, which simplifies to negative 8,30. So 8 divided by 3 simplifies to 2,67. 2,67. So therefore it means that the point of inflection is going to be at x equals to 2,67, and then y is negative 8,30. So that is going to be the point of inflection. Again, the point of focus is the applications of derivatives. So we apply derivatives to finding the gradient of the tangent. We apply the derivatives to finding the turning point of any cubic function. We apply the derivatives to finding the point of inflection of any cubic functions. But we will explain further when we engage live. So for now, I want you to get the idea of what we really are talking about. Then the other application of derivative, which is the last application in calculus, it is called applying derivatives or calculus to scientific problems. So it's like you are using them to do science. So let me explain the concept here first. Now, let's say you are given ST, and ST is the displacement or the distance covered by the object. When you take the derivative of ST, you're gonna get velocity. When you take the second derivative of the displacement, the original function ST, you're now going to get what we call acceleration. It's as simple as that. So you're given ST, they're going to tell you that this is the displacement or is the distance, or they're going to tell you that it measures the length of the object and all of those other things. You must underscore displacement, the distance, or the length traveled, somewhere along those lines, measuring the distance. Then when you take the derivative of that, you're going to get the velocity. And then when you take the derivative of the velocity, which is the second derivative, you're going to get the acceleration. So when it comes to the applications to scientific problems, this is how it works. Now, let's read the equation of the motion of a bouncing ball. So motion. So this thing is now in motion. So when something is motion, you would like to know it travels from which point to which point, for how long, and all of those things, or for how far rather. So st is t negative t squared plus 5t, where t is the time in second and s represents the distance. Underscore that. S is the distance. So it means that if you were to take the derivative of that, you would get the velocity. If you were to take the derivative of the velocity, you're going to get the acceleration. So let's answer the question. The question then says, determine the following. The height that the ball reaches at t equals to 2. Remember, what is s? S measures the distance. So we have got the distance formula already. So you're going to replace t by 2 to understand how high will the ball be after 2 seconds. So 1.3.1, we are looking for s of 2. So that's going to be negative, open bracket, all squared, plus 5 times 2. So 5 times 2 is 10. 10 minus 4 is 6. So that's going to be 6 meters. Because you are talking height or distance. 1.3.2, the velocity of the ball at 2 seconds. So what they are looking for here is s prime of 2. That's what they are looking for. How do we know this? Velocity is the first derivative. So we're going to find the first derivative. You take that thing and you find the derivative of that thing with respect to t. So that's going to be 2t plus 5. And then you're going to replace t by 2. Because that's going to be negative 2 and 2 plus 5. And that's going to be 1 meters per second. Because we know that velocity is measured in meters per second. And then 1.3.3. It says that find the maximum height that the ball will reach. So again, so this is the same as you are calculating the turning point. So in calculus, when you want to maximize or minimize something, remember in level 3 they taught you that when you want to maximize a function or minimize it, you find the first derivative, solve for t, and take that value of t, replace it back into the function. So here we're gonna do this thing as if we're calculating the turning point. In any case, the ball goes up and reaches the highest point and goes down. So we want to know the maximum height. So it means that we're talking about the turning point. So how do we get the turning point again? You're going to take the first derivative equal to 0, and this time around you're going to solve for t. So we have the derivative already, negative 2t plus 5 equals to 0. Solve for t. T is going to be 5 over 2, which is approximately 2,5. Then find s of 2,5. So we're going to have negative and then 2,5 all squared plus 5 multiplied by 2,5. So that's going to be negative, open bracket, 2,5 close bracket squared plus 5 multiplied by 2,5. And that's going to give us 6,25. So the maximum height of the ball is going to be at 6,25 meters above. And then 1.3.4, very easy. Acceleration, symbolized by small letter a, is always the second derivative. So me and you, we know the first derivative. When you find the derivative of that thing, the derivative of negative 2t is negative 2. And then the derivative of 5 is 0. So it means that's going to be negative 2 meters per second squared. Those who did physics, they would have an idea about the units of measurement, but that's not the serious thing for math students. But we will make it make sense when we go live. So that's how it works. So I'm not gonna record further than this. Just understand what we are talking about. The first thing that we have spoken about is the rules of differentiation. Like there is nothing that you're going to get right without understanding the differentiation, because it's the question that takes a lot of marks. And then there are 3 applications, or 4 rather. there are 4 applications of derivatives: finding the tangent, finding the turning points of the cubic function, and finding the point of inflection. So those are the 3 that are applicable to algebraic graphs. Number 4 is to the scientific problems. So remember, to the scientific problems, we are saying when you are given the displacement or the distance or the equation that calculates the length covered by an object, when you take the derivative of that, you get the velocity, and then when you take the second derivative, you're going to get the acceleration. All of these things put together, they formulate what we call differentiation in NCV level 4. Let's state exactly what that is. So I'm not writing, I'm simply going to state what you need to know. Number 1, you need to know first principle. Number 2, you need to know all the rules of differentiation: power rule, product rule, quotient rule, chain rule. And then applications: how to find the tangent, how to find the turning points, how to find the point of inflection, how to find the velocity and acceleration. So please interact with this, and then after having interacted with this, it's gonna make much more sense when we engage live on Thursday. So this is sufficient for you to get rolling. So I'm just going to also share some questions that we can do to just make sure that you understand exactly what you are doing.